All right, so let's get started. Welcome to Trends in AI, the November edition. My name is Jakub Zavrel, and I'm here with Dinos.
Hi everyone, my name is Dinos. I'm doing AI research here at Zeta Alpha, and we're going to dive into some pretty interesting news and trends and papers from the past month. Let's get started with it.
So we have a lot of stuff. Certainly, last month we ended on a kind of contemplation on the AI pause that it didn't happen. Well, for sure it didn't happen. So much new stuff came out now in last month. So we're going to give you a good tour through it, and let's start with the news.
So,
what was the most kind of headline news that you noticed?
The past week I've been trying to catch up with everything on Twitter and all news sources, and the one thing that came up every day is safety, AI safety.
Right. And I think this cryptic, so it's not a hash code, it's a number. This number came up a lot, right? Do you know what it is?
Yeah, I've seen it a few places actually. The most recent was the executive order from the United States, right? And this is to set the kind of the threshold where big models begin, and that could bring catastrophe, I guess.
Yeah, so this the number of floating point operations beyond which something is considered a frontier model and worth reporting. So AI regulation certainly grabbed the headlines. Well, the first news that there were a couple of people that wrote position papers on it. You remember the question whether any of the doomers had actually written anything about the topic. Well, this paper, Managing AI Risks in an Era of Rapid Progress, was co-authored by many of them, including Benjo and Hinton, I think. But there's obviously the European AI Act. It was supposed to be ratified this year in December, but that's not going to happen.
Really?
Yeah. So the lawmakers went through another discussion on it, and they struggled to find agreement. And it's especially the topic of the foundational models, as they call it, and the position of open source in that kind of divided the discussion. And what happened then is that basically the US, the White House, stole the show, right? They just launched this executive order. I think it came pretty out of nowhere, almost. There was
some events in the previous months that kind of hinted that they're looking into it more and more. And
there were all these hearings in Congress, and apparently they have been listening very well during these hearings, because they basically have now this executive order that requires, it's not a law, but it's like a presidential order until the next president comes, that requires these very powerful AI systems to be examined by the US government. And this number is the threshold, right? 10 to the power 26. Floating point operations, that's considered a frontier model.
Which is either that or some capacity in the cluster that is training the model.
Or the actual cluster itself. I think somebody did the math and said the cluster has to be about 50,000 H100s for it to fall in this into this category. So I'm not sure OpenAI has that, but it's a very large cluster. What I find interesting is that they kind of all of a sudden started using this phrase frontier model. A month ago it was foundational model, more or less. And where does this number come from?
I wonder, I don't think the White House came up with that number.
No, they've been listening very closely. And this fantastic journalist, Karen Howe from The Atlantic, she just pointed out that it actually comes from the OpenAI position paper on exactly this topic. So they asked to be regulated in a very certain way, and that's exactly what they got.
Seems like the White House overfitted on some of the frontier labs.
Exactly. Well, if you only have a few of them, and they're all in the US, I think the policy is going to be a little bit biased there. So basically, this fight broke out online, as you might have noticed.
Yeah.
So there's like OpenAI and Google and Anthropic on one side, and the rest of the world on the other side.
Pretty much, yeah. And a few free thinkers taking either positions.
So in particular, Jan LeCun goes pretty ad hominem. He says Altman, Hassabis, and Amadei are the ones doing the fear mongering and the lobbying. And he accuses them of not doing a good service to the AI research field. And there's this competing petition, the anti-doomer petition, you could say.
Or the open source movement.
The open source movement, which is now largely supported by, by Hugging Face, of course, but from the large tech companies by Meta. And it's this joint statement on AI safety and openness. So I signed it.
You did?
Yeah. I'm a fan of openness, and
I think
that's good for progress, but also good for safety.
And I mean, the statements were pretty reasonable. Nothing that could get out of control without anyone saying, "Hey, something's going wrong here."
Yeah, and one thing doesn't per se exclude the other, right?
Yeah, exactly.
Lobbying for a solid position for open science and open research does not exclude per se liability and safety for products that are being developed.
Yeah, right. I think on this topic, I also saw a lot of people on Twitter discussing that, okay, we have this whole discussion on what models could do in the future if they get bigger and bigger, but there should also be this discussion of what happens now. What do these models do already that can be causing harm without us realizing it?
Yeah, and I think open research is the biggest contributor to that understanding. And actually, some of those positions might turn out to be a bit different than we think, right? There's plenty of discussion about regulatory capture. So basically, the big guys want to be regulated to prevent small guys and open source from threatening them. There was also this AI Safety Summit. That was the other major event in the UK. So Rishi Sunak made it a big deal that everybody would come to the UK, and the UK would become kind of the global hub of AI safety regulation. He wanted the sort of International Institute for AI Safety to be founded there. It didn't happen. He was a bit disappointed, I think, but everybody came. So the pictures are kind of who's who, both politicians and industry. Microsoft was there, Amazon was there, Google was there, European Union, Ursula von der Leyen, Kamala Harris is there. Interestingly, Sam Altman is there, of course.
You can imagine the conversations got a bit heated with the events that took place the previous week before that summit happened. So
I think Jan LeCun was also there. They sure might have had more than a good dinner over in the UK. Certainly, Elon Musk was also there. I don't know if he's part of the Frontier AI labs, maybe.
We don't have it here, but this morning he tweeted they're dropping something tomorrow for the XAI.
Right.
So
how many parameters?
Nothing disclosed yet.
under the Frontier threshold, I guess. And well, what ended up, apart from kind of a very broad international meeting, even Chinese representatives were there, and it was pretty global. They dropped this declaration, which has only very few parameters. I think it's pretty short, but it's a good sign of intentions. So I was a bit peeved by this headline that I read in the news. Anthropic, Google, and Microsoft and OpenAI announce the Frontier Model Forum and a new AI safety fund, and they're donating a full $10 million. I know journalists are not that kind of good with numbers sometimes, but it's a couple of zeros less than the number of flops. So in particular, I think it's very ironic that we talked a couple of months ago about Microsoft investing 10 billion into OpenAI, and then you add up all the other investments, and this is 1,000 times less.
from four separate organizations.
From four of the biggest
leading.
tech company, two of the biggest tech companies and their AI labs, so to say. Yeah, I think if you dropping 0.1% of your income on a charity, I think it's kind of ethics washing. So let's dive into more technical stuff. It's launch time. It's been a very busy week, very busy month with new releases. Mistral came out about a month ago with their model.
We barely mentioned them, so we were coming up with the releases last month. Yeah.
And
but they've changed the fields. I think it's safe to say that everyone is hopping onto their previous fine-tuning methods and applying them onto Mistral because apparently something makes it so good, and it has to be.
It's a very small model, but it has the quality of much larger models. Yeah. And just this week, this yarn method was applied to Mistral, which extends its context length to 128,000 tokens.
Which was already trained on a sliding window with, I think, 8,000 tokens of the context length. Yeah. And now they're extending it even further. And I think as this graph shows, yarn works and you can extend it.
Yeah. And it's a very simple trick, actually, right? You don't even need to fine-tune it for the whole context length. It's just these rotational position embeddings that work generalized very well to longer context. We also picked up this release of OpenChat, which claims it's already on par or a little bit better in some areas than GPT, the March version. Sorry, GPT 3.5 Turbo, the March version. So it has not been verified independently yet. And I think the current version is a little bit better than the March version.
I mean, it's been fine-tuned on more user interactions, so as you'd expect.
And I think this is a LLaMA-based brew that OpenChat is doing here, but we'd have to check. This is not an actual launch, but it's a preview. But
I guess they were too excited and they had to share something.
It was launch week, so just drop something to get noticed. Now, so obviously DeepMind has made an enormous splash in all of the life sciences and biochemistry with their release of their open sourcing of AlphaFold. And now they are reporting that they have a new, much better version, which is doesn't have a version number, but it could be version 3, I think. And it's to be seen whether they're going to release it. For sure, it has a lot better accuracy just on protein folding, but it also has very high accuracy in all these kind of related tasks, like for example, protein antibody binding sites and different kind of structural changes to the protein that have biological significance.
Yeah, and they're definitely leading the field there. I'm not sure if I can recall off the top of my head any large organizations that is doing as big of a work.
Meta had a competing protein folding model, but we'll see how they will stack up. And also for the image generation model, a couple of notable new releases. Here, Ideogram is not such a well-known one like DALL-E or Midjourney or Stable Diffusion, but it's a similar style image generation model based on diffusion. And the forte of Ideogram is that is really good at rendering letters. So I think it's very interesting because for a lot of commercial it's creative style, it's really important to get the text right.
And it's not common in modern models. I think anything up to DALL-E 2 could not do it. I've seen some blog posts from DALL-E 3 saying it's a bit better in that direction, but
still, I've seen horrible exampple from DALL-E 3. Exactly.
I would not put my money on it.
And this other one you noticed, Stability.
What is that? They're coming forward with models to generate 3D, anything in vision that involves scenes, and I think it's also an extension of their work on the stability diffusion.
And what does 3D mean in this context? It's an actual like nerve style rendering of objects, or
I think I didn't go too much into detail, but I think so. Yes.
Yeah.
It's really
and by the way, I saw also that Runway just released yesterday a new video model, which looked very crispy and nice, high definition, very aesthetic videos. More launches on the dataset front. So Together AI announced the release of a new version of RedPajama dataset that's been used for a lot of the LLaMA style.
Yeah, everything,
models.
every language model is trying to pull as many sources as possible to get those tokens up.
Yeah.
So yeah.
This is a order of magnitude increase, right?
It's an impressive 30 trillion tokens, which I don't know how unique these tokens are. There's also this study that came out, and they benchmarked the previous version of the RedPajama dataset, and they found that I think at least half of it was duplicates. Yeah. And there was significant data contamination with common benchmarks from glue and superglue.
Right. So it's not that useful for kind of research style things, but maybe for commercial use that doesn't matter so much. What I cannot wrap my head around is how you can take 84 common crawl dumps and not have like 90% redundancy in there. I mean, these are not like, different internets that they're crawling from different planets.
Yeah, I guess they have a solid pipeline for duplication. And I also know that Alan AI has done a lot of work in open sourcing such tools. But yeah, I think there's always, whenever new dataset comes forward, I think we need to be a bit cautious with, it's 30 trillion tokens, and yeah, maybe it's not all good.
No, quality matters, right?
Yeah,
like we know from some of the other papers, you can actually achieve much better performance with a highly curated data set sometimes. So on the search and information retrieval front, a pretty big splash was this week. Niels Reimers announced this Cohere version 3 embedding model. I think Pinecone also announced a new embedding model. Their forte is that it can chew up really long token sequences. But Niels actually spoke about this model at our workshop.
Yeah, without naming it, they said that this research on high quality data and discriminating between good documents, bad documents, informative, goes a long way to retrieval performance. So
they temporarily captured, I think, both the beer and the MTAP leaderboard, but we know how temporary that can be. It's a race. So everybody needs a lot of GPU, 50,000, if I'm made to believe, to be taken seriously in this world. Maybe you get a ticket to the next Bletchley Park summit when you have that. But probably you can buy them cheaper from AMD. We reported a while ago that they are really good, doing very well in capturing the PyTorch ecosystem and making that work really well on their chips.
And Hugging Face supporting cross-card, cross-architecture training.
Exactly. So this MI300 is nearing its release, and now there's some really serious reports actually from the financial analyst call of AMD, where they predicted that next year they would do 2 billion of revenue in AI data center compute, and that if it's like said by the CEO in an official analyst call, it has to be supported by real orders. It's not like they made this up. So presumably, all the big data center providers have actually ordered very large batches of these chips, and they are actually kind of in the process of being manufactured. So exciting.
I mean, more GPUs can never be a problem up until that threshold.
I wonder what the price will be. That has not been announced yet. So certainly cloud providers are not doing badly on all of this AI compute hunger. So from the financial calls of the big cloud providers, in particular Microsoft and Google, there are some pretty strong growth numbers in their cloud divisions, except that Microsoft is growing more than 20%, actually 29% in Azure, and Google is only growing, I think, single digits or very low double digits. So
that's a significant difference.
That's a pretty significant difference, and they were already behind. And I think it's a bit of a testament to the fact that they're still struggling to really release these models as products.
Do you think that the OpenAI collaboration really helps Microsoft's selling points?
Absolutely. I mean, when we talk to customers, basically calling the OpenAI API in Azure is like a no-brainer for them, because most of the large companies are already in Azure, and they're just consuming those tokens like crazy there. Yeah. And actually, I don't know if you've experimented with some of the Google models.
Yeah, only the public ones, like through Bard. But I mean, even Google's documentation has references to, oh, this is how you do it in OpenAI. So they're kind of admitting that, yeah.
Yeah, the Bison
most
model,
people have
the Bison model is not there yet. So we'll see what they bring next month, maybe with Gemini, but they're not there yet. All right, in a slightly different topic. So there was also in the courts a lot of activity around AI. There was this court case filed by a collective of individual artists against Stability AI. I think that's of a slightly different order of magnitude than the case that was filed by Getty Images against OpenAI, I think. That still hasn't been decided, but basically here the judge dismissed the claim. So yeah, I think it will go on probably, but it's a first loss for the artist, and
I'm sure that extends to
Stability.
A lot of angst for people with copyrighted material in text, because we know that many people are very careful with publishing details about what they're training on, just because you never know.
Yeah,
maybe a future decision will be against them.
That's right. But yeah, this one, I didn't expect this one, actually. I thought the courts would be more on the side of the creators. Right, in funding, well, the enormous amount of funding still goes on, almost kind of repetitive here, right? Google commits to invest $2 billion in Anthropic. I think last month it was Amazon, right?
Yeah.
Same amount. So I think they now secured that Anthropic will still use the Google Cloud, I think. Mistral is also raising funds again. So they're allegedly seeking another 300 million investment. They haven't closed it yet. And I like this headline where they called the wannabe OpenAI of Europe. The company is like 3 months old, right?
I mean, everyone is using on the open source.
Yeah, their release was quite a success.
And it's also quite good press for Europe, because before we never had this really. I mean, if you consider LLaMA to be a European model, but Mistral is really people that have been from Meta's team in Paris, right?
Yeah, so I feel really bad for, that's why I put this little press release here, for Light On, which was actually the French champion of open or European based large language models. They actually contributed to Falcon, I think. Their team was on the Falcon papers, but they didn't get as far as Mistral in capturing the attention. They made a partnership with the French Post. So
and Mistral did it with an unorthodox way. Just drop the weights, our product release, and then a few days after, okay, let's actually tell people what we did.
Yeah. In China, also similar numbers are going around. Thanks to reporting in TechCrunch, we found this snippet that the Beijing-based company Zephyr AI is raising 340 million from a consortium including and Alibaba, Tencent, and Xiaomi. Zephyr is a very interesting company. Have you heard about it before?
No.
It's actually the man behind it is Ji Tang, who's a professor at I think Beijing University, and he's the guy behind GLM and Wudao and all these kind of earlier very large Chinese models that came from the academic world. So talking about the academic world, there are still conferences, even though AI is shifting more and more to closed and commercial releases. This last week we had CIKM on the sort of search and information retrieval side in Birmingham. The papers for CIKM are streaming into Zeta Alpha as we speak. You can consult them next week. And the conference hasn't been live yet, ICLR, but the papers are. It's
the anonymous versions, yes.
The anonymous versions. But in Zeta Alpha, you can pretty easily find out who they are. Not recommending that, but it's about 8,000 pretty high quality papers among them.
Pretty technical,
well, not all
pretty advanced.
Not all 8,000 of them are going to survive. Not all 8,000 are high quality, but there's some really interesting gems. There are a lot of stuff around proteins and chemistry and things like that from large labs. So check it out in Zeta Alpha. Talking about Zeta Alpha, so if you haven't tried yet, we're building this very intelligent discovery platform for content in AI and data science and beyond, also for private content, where you can organize and discover interesting papers, hot off the press or older papers in your own topics, and
get personalized recommendations.
Get personalized recommendations. That's how we find all the new gems. And of course, retrieval-augmented generation plays a very important role in our world because it's kind of the only way to really make large language models work well on recent and proprietary material.
And we'll see a lot of that in the selection we've made today. Yeah,
there's a lot of stuff going on in retrieval-augmented generation. And this allows us to basically directly do conversation, answer questions from internal documents. So we're using that more and more from Google Drive, from GitHub, SharePoint, Confluence, all those kind of sources. And last month we launched this chat with papers. It's also retrieval-augmented generation, kind of limited to one paper. You can ask questions, extract data, find related material, and that all integrated into your workflow.
Good thing this is not only our only product with chat, because a lot of people got scared this week on Twitter with OpenAI saying, "Oh,
chat to PDF." Now. Well, if you only do that, then, that's not integrated yet into a lot of workflow stuff for corporate IT. And now, just a little sneak preview. Next week, we're launching another update of that we call the Knowledge Assistant, where you can basically use mixed initiative dialogue, multi-agents, LLMs, and tools with retrieval-augmented generation to help you get work done faster on document collections.
Mm-hmm. And I think this will take a bit of time for OpenAI to catch up with us now.
So it's I think they're close to that, but it's not as integrated into kind of a real workflow.
And the power is in the documents. So I mean, if you always know which document to ask questions to, it's easy. But then What about discovery? What about helping the user find what they want to find?
What I really like about this new functionality is that it's mixed initiative. So if you don't exactly know what you're looking for, it's not you prompting the model and then kind of correcting its mistakes, but it's kind of helping you by asking questions. And that's what a really good coach does. So we'll launch that next week in Washington. But let's go into more the research side of things. The trends in AI for papers for November. So this is the yield, right? A lot of papers came out. I think about 8,000, 9,000 new papers here clustered based on their embeddings.
Yep. As always, we have this large red chunk, which is, as you guessed it, language models, large language models. But we do see a lot of interesting stuff that is not there every month, I think, like time series forecasting, which turned out to be pretty big this month. Of course, we have diffusion, vision, language, graph networks, which we always see, but let's focus a bit more on our kind of expertise, language models and retrieval, right?
So the first one that we picked is actually a very nice information retrieval paper. This is joint work between the University of Waterloo and Microsoft Research. And basically, they looked at all these new releases of open language models, and they asked the question, can we actually use them for ranking, right?
Pretty fair question.
So there's kind of two things. All sort of the the earlier this year released ranking and embedding models are mostly based on like BERT style models or T5 models, especially for re-ranking. T5 has been dominating the information retrieval field, trained on MS Marco. And then there was this kind of first glimmer of using GPT for ranking. Among other things, RankGPT basically cast ranking as a text generation problem, right? Here's a list of documents. Give me a new ranking for them, or give me some ranking scores. They tried multiple things. But the thing is, RankGPT, of course, is not trained on MS Marco. It's just kind of zero shot.
Yeah.
And even though it's using GPT-4, yeah, it only uses the knowledge inside the parameters, but doesn't actually know all that much about ranking. And the BERT and T5 models by today's standards are pretty small. So Ma Wang and others, with the help of Jimmy Lin, they basically took LLaMA 2 and they fine-tuned it to build both a dense retrieval, so an embedding model, kind of using the same approach that people have done with BERT model. They just like attach an extra token to the sequence, and then they read out the layer before the last one as an embedding, and as a pointwise re-ranker. The same way that it was done by using T5 as a re-ranker, just concatenating the query and the document and then training it to predict the relevance score. And, well, not such a big surprise, maybe, but it's a pretty good system. So in these tables here, you can see that RepLLaMA and RankLLaMA, as they call the system, achieves state-of-the-art performance on MS Marco. That's the table on the top, both among dense models and also beating rank T5, which was the previous state-of-the-art. And also on Beer, which is a zero-shot benchmark, so no training data, they get a very good score. An interesting section of the paper is actually where they point out that because you use LLaMA, you have a much larger context window than either BERT or T5. So they actually is less of a need to slice documents up into passages because you can cram around 4,000 tokens in one embedding.
But I also assume that since it's a decoder-only model, you don't have the 700-dimensional vectors that you had with BERT, right?
No, so you also end up with 4,000 dimensional embeddings, which is for production is still like a lot of storage. Right, so I think retrieval is these days mainly used as a part of retrieval-augmented generation, question answering by retrieving documents and then templating them into the prompt. This paper here, FreshLLMs, looks at search engine augmentation and has two contributions. One, it builds this benchmark with questions that are not easily answerable from pre-trained parameters. Basically, questions that require either up-to-date knowledge or knowledge which changes very rapidly, where you need to do a web search to get the most recent state of things, or questions which have false premises that need to be kind of fact-checked. And they show that basically even GPT-4 does not do a very good job on these type of questions. Around, I think, 10-12% correct on fast-changing questions, which is no surprise, right? Because how can you know? So what they do is actually introduce this new style of prompting as well, which they call fresh prompt, which is a fairly simple, simple approach, which is basically a few shot prompt, which shows the model how to do a little bit of reasoning about time. And apart from giving an example with search snippets and then an example reasoning step and then the correct answer before actually asking the question and giving the retrieved evidence for that question, they also do this little trick that they just mark all the different fields and they very explicitly give the date of each of the snippets. It's a simple trick, but it seems to work really well. And unsurprisingly, they managed to lift the performance of GPT-4 to a pretty decent 70-80%. More retrieval-augmented generation goodies.
And I feel this is a similar paradigm with the previous one. Here, they're taking a step back and thinking, okay, where does retrieval-augmented generation fail? And one of the cases is simply you don't need to retrieve. The model knows the answer. So if you just keep adding noise from retrieving stuff and then having the model combine all that information, then maybe it makes a mistake. But then there's another case where it's much more frequent, and we see it every day. Is what if you don't retrieve the right answer in the passages that you use your retriever with? Then you basically prompt your model with wrong information, and then you're poised to get it wrong. So this is kind of the preface of this research work by Akari Asai and others at the University of Washington. And what they practically want to achieve is a language model that can reason about these factors of, do I need to retrieve, first of all? And when I retrieve, what I retrieved, is that relative, or will that help me create a good answer? And another step forward is, I generate an answer. Do I really base it off the retrieved passages, or did I maybe hallucinate somewhere along the way? So what they do is a very nice idea. They don't try to mess with reinforcement learning, but instead they want to first train a critic model. And this critic model basically annotates the training corpus where you have normal questions that users might use. And then their idea is, first, let's use GPT-4, which can probably detect when some information might be appropriate to be retrieved.
Right.
So they insert these tokens that GPT-4 output as, okay, retrieve now, or let's reflect on if the retrieved passages are relevant. And so you can imagine you have a large corpus of questions and generated conversations that have these tokens, and then you simply train a language model on top of that. and these tokens are actually tokens from his vocabulary. So as that generative model will start answering a question, it will by itself stop and say, okay, let's retrieve now. And you can configure these with thresholds.
So these tokens are a little bit like tools to guide the reflection on
so
on the previous
you have to support
answer.
it with your inference library that, okay, this is a special token, this means something, don't keep generating.
Yeah.
But once you start adding this information, then we do get some performance improvements. So if you go on the next slide, they show that this actual very simple method that works with small enough models. So I think they used LLaMA 27B and 13B, and they show that retrieval-augmented generation with their models outperforms LLaMA in any case, LLaMA chat even, which also trains with reinforcement learning. But in some tasks like question answering, fact verification, and reasoning, in some datasets, they even outperform ChatGPT. And one very important aspect that this method kind of helps in is also have this factuality and citations, because this is inherent to the model. It's learned to always check back to the passages that it used for the answer.
Yeah, so citation is like a special token or of some sort?
I mean, it's not a token per se, but you can see that from its reasoning, it assigned a high score to a retrieved chunk. So you can use that very confidently and say this was the passage that I use, and not in a very vague way, oh, this was the evidence, and I have to do the matching somehow myself.
Cool. And you do need to make some adjustments to how you decode, basically.
Yeah, of course. But I think this paper came out 2 weeks ago, and of course there was LLaMA 2. Let's try Mistral. Another research group tried it, and it's even better apparently. So this is a very promising direction.
Interesting. So more retrieval-augmented generation. This is more really kind of an analysis paper, kind of a probing paper. Doesn't really propose a new model, but it constructs a data set of long-form question answering examples, and then goes into meticulous detail, kind of sentence by sentence. So if you have a model which gets a bunch of retrieved passages and it generates a long-form answer from that, they analyze sentence by sentence where the sentence is coming from and whether it's actually supported by the retrieved material. And they find all kinds of interesting cases there. And yeah, it's a really good read, and I can recommend going through all the examples and kind of sharpening your understanding of how retrieval-augmented generation can go wrong. Obviously, they find that yeah, if the retrieval engine doesn't deliver the relevant passages, that's a big source of failure. But there's many other what they call hallucinated facts as part of an answer, which are not necessarily incorrect, but they come from parameters of the model. And yeah, that's not really something you want to suppress. So I think it's an interesting data set to further study this. Incorrect synthesis is where it kind of glues together sentences from two different passages in the wrong way, but there doesn't seem to be a really strong source of problems.
And unfortunately, for long form generation, you always have to kind of go deep into the data and see yourself, because we don't have the metrics that accurately reflect what's happening.
It's very hard to evaluate, and they did it kind of the manual way here. And I just wanted to highlight one little illustration from the paper. So this is the probability that the sentence will not be supported by the retrieved passages as a function of the position in the generated answer. And what you see here is that the last sentence is just always at risk to be wrong. So this is, I recognize it. It's like everything is correct, and then it messes it up with one really bad hallucination at the end. So I think we'll have to fix that. All right, so this is still about kind of retrieving, but also storing information, right? MemGPT, very cool paper.
Yeah, this was definitely an interesting read. So now they're taking us back to way before large language models. So they're trying to solve issues that we encounter with context and memory within language models, but with how people have been solving them for decades using analogies from the operating system world.
So what was the core problem that they're solving here?
So, of course, language models have a very limited context length, and of course, there are many methods that are trying to extend them, but you always have this trade-off of, okay, even if I support 1 million tokens, do we really process them efficiently, and are they all used when coming up with answers? So what they did is they tried to give the illusion of an unlimited context window, similar to how your computer makes you think that you have terabytes of memory, when in reality, the CPU can only access some gigabytes of it. So again, they take this analogy with a main context window or memory and an external context memory. In the main context, you'll have your instruction, your system prompt. There's some conversation history, so the model knows what's happening. And then you need to leave some space for the model to actually do reasoning. And then everything else, so they come up with two kind of external storages. One is the archival storage, the general purpose, which could be a database, a vector storage, anything goes, and a specific, I think, example that they use for their use cases of a recall storage. So basically, they log the events that the model has processed, so then it can recall and say, oh, this happened in the past, maybe that helped me find information more efficiently.
So basically, during the conversation, the model is making decisions to offload parts of its context into the memory and clean that part out.
Exactly. Yeah.
Or reload back some earlier part because it thinks it needs earlier information, right?
Exactly. So they've augmented this language model, which is GPT-4, with functions. So these functions can basically interrupt the flow and give it back to the user, or let the LLM do some more processing before answering. So there's an example in the paper where, for example, the model tries to store something in its context, but then it gets an alert from itself, basically, that's saying your context is pretty much full, empty it and store it. And there have many examples where this they kind of focus in two cases. One is this conversational scenario, and there they really show an advantage of being able to store unlimited memory externally, basically. So you can imagine in one day you wake up, you say, oh, it's my mom's birthday tomorrow, I'm going to bake some cake today. And then 2 days later, it will ask, oh, good morning, how was your party yesterday? Which is really cool. And language assistants cannot really do that without trickery. And then they have the other case, which is more interesting, I think, to me, which is this long document or multi-document analysis. And their results are kind of mixed. They admit that they did not go into depth. For example, they use off-the-shelf OpenAI embeddings, and they just compare with a baseline where you just feed the top K documents to GPT. But in their scenario, it's more like a paged mechanism of how a computer works with. You fetch 10 documents, and then the model can choose to fetch more and more and more. And there they see that currently the language model is not that smart of how it handles that.
I like this idea of a kind of storing instructions for itself a lot, right? It's kind of, in some sense like a reminder note to come back to an action at a later point.
Yeah.
Like a kind of an interrupt in the classical.
This is a really
processor.
Cool paper, and it's also open source, so people can dig into it, see the prompts they've used, because I feel like they really gear towards this conversational assistant and more not into the more general purpose. But since it's open source, people can.
Yeah, I think it's really interesting where this will go if you extend it more into the planning side of things, right? Like a planning agents which can do bigger tasks over a longer period of time. So check out MemGPT. This is a very technical paper.
Very punchy headline.
So it's kind of a clickbait headline, but it's true. It's true. They can do it. They achieve sub 1 bit compression. So they take less than 1 bit of storage per weight of the network, and they basically managed to take this very large 1.6 trillion parameter switch transformer, which obviously consists of many smaller experts, right? So here in this lower left-hand side diagram, you see kind of the tokens are routed by this routing mechanism of the mixture of experts to be given to one particular expert. And there's, I think, in this switch transformer, thousands of these experts, and they're not all active simultaneously.
But you do need to have them in memory in
But
case
you need to have all the weights in memory, and it's a whopping 3 terabytes of RAM that you need to do that. So you can only do it on a TPU pod or a very large GPU cluster. So not that many people have been successful in replicating this switch transformer. So what they managed to do is actually compress it down to 160 gigabytes, which is a factor of around 20.
20 years.
Yeah. Using a couple of very neat tricks. So first of all, they do quantization, like in QLoRa or what is this other SPQR?
SPQR,
yeah. So basically, using some real data from the data set to estimate kind of bins for the weights, and then represent them using fewer bits. But then you still have a lot of weights. You can, if you go down from 16 bits to 4, you achieve the compression of 4x. Mm-hmm. So then they notice this other thing. These sequences of bits are very have a very low entropy. So you can basically compress them. So in the second step, they just use something like gzip, you could say, to just make a compression of all these large sets of weights. And yeah, because many of them, if you use 4 bits, yeah, there are many zeros there and many sequences, you can be very successful with that. And so that's how they achieve a total of 0.8 bits per weight. So I think that's pretty impressive. And the most impressive thing is that they actually managed to run this very fast on a GPU. So they use this dictionary of code words, which unpacks these compressed representation in the GPU in very few steps. And yeah, I think they lose about 5% of runtime.
I think that's pretty fair. If you can
very impressive.
Use 20 times less GPUs. I think they have this diagram here. So, for example, I don't think anyone had access to 130 3090s, but now if you just have a cluster with 8, you can run a trillion parameter model, which is impressive.
Run switch transformer at home. What about this one? Large language models cannot self-correct reasoning yet. Yeah. It's kind of the opposite of the other paper, right? Where it says like self-correction is the key to better question answering.
Yeah, I feel like this is a criticism paper from Google, which is not to throw jabs at other people doing research, but more to kind of motivate people on how or which are the important areas where we should investigate language models in. And their premise is basically that when you have a language model that outputs something wrong and you tell it, oh, this is wrong, think again, you're kind of biasing it into giving it another chance. And if you do it systematically on a benchmark, this is equivalent to leaking the test set, because you give it the information that this was not the right answer. Like, so try again.
Is it answer A or B?
No, it's not A.
No, it's not A. Okay.
Yeah, and they actually show this with an experiment that if you just take away the language model and just have random resampling of the remaining answers, eventually you'll get there.
Yeah, but this is only true for like you know, for questions where a clear gold standard answer is right. Really summaries, etc. It wouldn't be subject to the same criticism.
So they're saying that in practice you don't have this oracle saying that this is not the right answer, and if you evaluate it more realistically, where the model itself should always say is this right or wrong, then what happens, and they show this with extensive experiments, that in practice the model will actually correct itself even if the answer was correct. Because if the prompt says detect your mistakes and fix them, the model will actually fix correct answers as well.
Right, which so it kind of goes both ways.
It's not what you want. And they show this in this 2 graphs, that of the percentage of the answers that they change, which is the not blue part, some is from wrong to right, obviously some are from right to wrong, and from wrong to wrong again. And this is basically kind of showing that the model does not self-correct its reasoning. It's just having another go, and maybe it gets it right.
Yeah. Stochastic parrots cannot self-correct.
So there are some cases where they claim that this is helpful. So for example, if you have a style to enforce, or you want the output to have a very specific format, citations and all that, then having another go will help, obviously, because then you're not just changing the output, you just enforce something to what already produced. So I feel like they make some propositions and where future research should head. They do have an example of this happening. So in this math benchmark, you have the model, maybe it answers something wrong. It says, find what you said wrong. And it says, okay, this is the wrong answer. I'll give you the right one. But it also goes the opposite way. And they find one case that does improve performance, as previously reported by other benchmarks, and this is when you have this multi-agent setup where models with different kind of expert prompts kind of critique each other. And then in this case, it does work, but then it's no longer the base model itself. You just kind of have an ensemble that tries to get it right, either through counting or majority vote.
Yeah, or kind of discussion when they have different knowledge actually to bring to the table. Yeah. So what's your verdict? Can they self-correct or not? It's a yes/no question.
I would say no.
No, because... that's wrong. Can you reconsider that?
Maybe.
All right. Last word hasn't been said on this yet. So we're going back to Mistral.
Yeah. This is
Hugging Face, right? This is Hugging Face remix of Mistral.
Hugging Face and OpenAI and voluntarily. This is not anything groundbreaking, but this is a very good proof of concept for the DPO paper that we showed a few months ago.
Yeah.
So what they want is to...
DPO stands for?
Direct preference optimization.
Right, so no reinforcement learning from human feedback.
The whole
just using supervised learning.
The statement there was that you can use supervised learning and implicitly you have this reward modeling taking place.
Yeah.
So it's really simple. First, you just generate output with language models to enhance this conversational abilities. So in this paper, they use a data set with 200,000 conversations from GPT 3.5. They fine-tune Mistral on that. And then they use a collection of language models, including GPT, LLaMA, Claude, and all these, and feed it to GPT-4. And they asked it to judge them, all these 4 answers on a set of prompts on factuality, honesty, helpfulness, if it follows instruction or not. So general stuff that you would want a model to have.
Right.
And then you use this DPO, again, distilling the knowledge from GPT-4 to your fine-tuned model.
Yeah, so it's in that sense just an example of creating synthetic data using GPT-4 and then distilling from that into smaller models.
Yeah.
And how well does it work?
It is pretty nice. I mean, they have this spider graph, I don't know what it's called. This is really not that clear to me how you read it, but overall you can say that Zephyr is better than LLaMA 70B, well, as you can see from these rings. But overall, that doesn't really give you a sense of, is it better or not? We have these classical benchmarks like MT Bench and Alpaca Eval, and then there they see that even competing with the larger models, it's actually not that far off, even with 10x models with 10x the parameters. And same goes with the more classical reasoning and logic and language understanding benchmarks that they use with OpenLLM eval. So it's a really good model. I've started seeing, I think people use it on u.com and all proprietary platforms, they offer it as an alternative next to LLaMA 70B, which is...
So is it better than Mistral by itself, or like as a starting point?
Well, this is at least what the paper is trying to prove here by comparing with Mistral Instruct. Although we noticed that actually on the OpenLLM benchmark, the official entry by Mistral is around this 64 mark in MMLU at least.
Exactly.
So
that's a bit...
again, that's just one data point. It doesn't say that if you don't play with the models, you won't have the full picture. But yeah, it's definitely going to be improvements in the other areas where the
so certainly kind of in the helpfulness and alignment instruction following department. Yep. So a worthy open source candidate to consider. Our second last paper in this session is the first computer vision. You're a resident computer vision expert.
And yeah, this is a multimodal model, and
it's a multimodal model. So it's a kind of like a clip replacement.
Yeah, it's a clip drop-in replacement. Again, not exactly, because it is a very small model, and what they want to show with this is efficiency, and the loss objective actually matters. So they have a 3 billion text encoder, which is trained with a UL2 objective from Zeta and al. And they propose this new. Actually, they're using an loss function which is called SIGLIP. I was not caught up on that. It's from March or May, I think, the paper. I asked our platform to explain to me what's the difference is, and this is actually just a point-wise loss on text image labels instead of clip, which kind of does a batch normalization. So small difference, but they show that this loss is actually much more efficient, and they can use a 5 billion model, and in total, the performance improves drastically compared to in other tasks other than classification, because width is trained with a classification loss. So of course it makes sense that here this loss is not as strong, but if you go wider into question answering tasks, and any task basically that really needs to align vision or understand what's happening in an image to answer a question, there this loss is really optimized. Basically the models are much more performant in that. And they also show that comparing with state of the art, which is again previous PaLI versions or Palm X and all these multimodal models, which typically have 10 times the number of parameters, this model is much more competitive, especially when you don't augment them with OCR. So it turns out that this training paradigm actually has an implicit OCR ability.
So it's not going to be that difficult to stay under the 10 to the power 26 flops
limit
boundary.
Yeah,
this is not a frontier model, but it is state of the art.
It is state of the art, and the training is pretty simple. Like, it's what you'd expect. First you train each encoder, then you mix them together and train on more data.
So is this a good model for people to consider building, like open source multimodal models? Is it open source actually?
I'm not sure actually. I think it is, but I have to check again.
I think, yeah, well, that's interesting, because I think
previous work from the same authors open sourced a lot of models.
Yeah, certainly VIT was open source, but a lot of Google research stuff these days is not so open anymore. All right, so that's the last paper. Is an overview paper about evaluating large language models. It just came out this week. It's a nice survey. It's a very important area, of course, because all these benchmarks like MMLU, they're really not very predictive of any sort of real-world performance of in a chat or assistant context or summarization context or any of that. So a lot of people, especially in industry, but also in academia, are struggling with evaluation. So you can check out this paper by Guo et al. That gives a nice overview of the recent works in this area, but there's also quite a lot of new tooling being released, and we're actually proud as Zeta Alpha that we just last week open sourced our own framework called RegElo, which is a very nice kind of benchmark-free evaluation toolkit. And what it does is actually use ELO-style tournaments to pit different LLMs or different prompts against each other, and then use GPT-4 as a judge, just not to give compare it to a correct answer, but to only say which version is better according to the evaluation guidelines.
And I really liked it because it's very versatile. It can do normal language models. It can handle the augmentation with the retrieval. It is very helpful when you want to evaluate all kinds of aspects, like you said, prompts, retriever models, language models. All that is encapsulated, and you just get one ranking.
Yeah, and it's kind of very simple standalone package that you can use just on outputs of any kind of system. You're not tied to any particular vendor or language model framework. There's obviously a lot of other frameworks as well. For example, Langsmith is the It's not ELO style tournaments, but it's kind of evaluation using GPT-4 inside LangChain. So I think many people will also be interested in that. Ragas doesn't actually do ELO style tournaments either, but more like a comparison to a gold standard. And there's also some commercial vendors like Galileo and Human Loop, which provide similar frameworks. And I think Judge LM is actually a pretty large fine-tuned model, which does the evaluation for you. So it's like a LLaMA 2 model fine-tuned on evaluating other models. So that's also an interesting approach. Definitely going to be big, LLM evaluation. And I think that was the last paper, right?
I think so, yeah.
So how are we with time? We need to wrap up. So this is our last slide.
So what's happening here?
There are two kinds of people. Can you guess which two kinds?
I can guess that some people are not very polite with their language models. They're very bossy, very commandative.
Exactly, and those people will maybe suffer in the AI singularity. So there are two kinds of people: the people who say please when they prompt a language model, and the people who just are very directive. And this paper, large language models understand and can be enhanced by emotional stimuli, kind of drives that point a little bit further. As well, it's not just please and being directive, but you can use your whole repertoire of emotional manipulation and social engineering to get better answers out of the language models. So for example, if you say, and by the way, this is very important to my career, that you give the right answer, it actually produces more accurate answers. And there's many other things like question, is it self-confidence? Are you sure? Are you very sure? And other kinds of social manipulation. So it's a fun paper. So what's next? Thanks everybody for tuning into the November version. We have lots of more events in November. Next week we will be in Washington DC for Knowledge Management World and Enterprise Search and Discovery, where we're launching the new Knowledge Assistant. Also next week here in Amsterdam, we're hosting the launch event for the Amsterdam user group of OpenSearch, also a very capable neural search backend. And we have cool talks about generative AI, retrieval-augmented generation.
Yeah, I'm looking forward to that.
And vector search in OpenSearch. And more events coming up also here in Amsterdam in 2 weeks is ChemAI. If you're interested in the applications of AI in the world of chemistry and pharma and life sciences, you should definitely attend this small gem of a workshop with Max Welling and other very high-profile speakers. And of course, NeurIPS is coming up. So our next edition will be on Thursday, not Friday, December 7th, and it will be a little bit of a preview and party around NeurIPS. So check it out. Join us for the next edition on December 7th. Thanks for watching, and thanks for tuning in online. Enjoy discovery.
Bye.